Let's talk about symmetry. For symmetry, it helps sometimes to look at a specific ordered pair. For instance, this point right here is the point 2, 4, and its symmetry point, its point of symmetry, or one point of symmetry, would be -2, 4. All right, we can see from the graph that this has origin with respect to the y-axis. And so the question would be, what type of symmetry does this have? It has y-axis symmetry, but they might just give you like the points or something like that. Sometimes they'll say something like, if you're talking about a point A, B, then what are the coordinates of the point with y-axis symmetry? And so you'd have to say, well, if it's y-axis symmetry, then the x coordinate is the opposite. And so that's kind of a property that you would notice. The next one, the next graph has origin symmetry, symmetry about the origin. And again, if you look at a specific point, like let's say this one right here, this is the point 1, 1, and its symmetry point, symmetric with respect to the origin, is the point -1, -1. All right, so I can tell from looking at the graph that it's symmetric with respect to the origin, but I'm telling you, they're probably going to ask something like this. If it's A, B, then basically what you're doing is taking the opposite of both of the coordinates, -A, -B. And then the last one, we can tell that one has symmetry with respect to the x-axis. And it's easy to tell when you're looking at the graph. This point is 2, 2. This point is 2, -2. You know, what I always think about is the if you have x-axis symmetry, then the y-coordinate changes. So, you know, here's a good question maybe. Let's say we know we have y-axis symmetry. Then the point -A, -B becomes what? And students have a hard time with this, all right? If it has y-axis symmetry, then what does this point become? And, you know, what I remember is y-axis symmetry, the x-coordinate changes. And so all I would do is change the x-coordinate, and so it would be this. If it has symmetry with respect to the origin, then what does the point A, -B become? Origin symmetry changes them both. So all you would do is just change them both. And so it'd be opposite A, B, something like that. Students have a really hard time with that kind of question, but I'm telling you. So if it has x-axis symmetry, and we've got the point, let's say -A and B. For x-axis symmetry, the y-coordinate changes, so that would become opposite A, opposite B, like that. Pretty tricky. Piecewise functions. I know students are kind of confused about this, but you've got to read this in two parts. First of all, you've got this equation, but you only want to look at that when x is less than -1. So people always kind of just ignore this part, but you can't. You can't ignore that part. That's like a divider line. Something happens when x equals -1. And so right here at -1 is kind of like the split. You split from one equation to the other. So if I was graphing that equation, y equals -1/2 x plus 1, Normally what we would do is we would start at 1. Wait, no. Scale's weird. Start at 1 and we go down 1 and over 2 and down 1 and over 2, and we would draw a line up 1 and over 2, up 1 and over 2, up 1 and over 2. We would draw a line that looks like this. But the thing is, we only are allowed to look at that graph when x is less than -1. So we don't want to look at this whole thing. We only want to look at, I don't know if I'm going to be able to do this, but we're only allowed to draw this thing from here and over. Think about it as the domain. The domain of that would be everywhere. Well, let's give it an open circle here so we make sure not to include that point. I want everything that's less than -1. That's the domain. All right, get rid of these points. I don't have these points. I'm not allowed to look at those points. So then the other part of this would be x squared, or y equals x squared, but I only want to look at y equals x squared when x is greater than or equal to -1. So x squared, we know x squared is a parabola. And normally what we would do is we would go here and up 1 and up 3. Oops, that's not 1. Forgot about my scale. This is over 1 and up 1. Over 1. Yeah, I totally messed up the scale, didn't I? Shoot. That is -1. So this parabola, it's going to stop right here. And then I'd go over 1 and up, 1, 2, 3. It's going to keep going to the right forever and ever and ever. It's going to look like that. So there's your piecewise function. Sometimes you have to look at the blue equation. Sometimes you have to look at the purple equation. But there it is. Now your domain, if you look at the x values that are covered, this looks like all real numbers to me. Everything's going to be covered. Even this open circle right here gets filled in by this circle here. It's going to be all real numbers. The range, though, you look at the y numbers that are covered, it only covers from 0 and up. So from 0 to infinity. Tough stuff. Composite functions, add, subtract, multiply, divide, and take a composition. Well, adding, you just add like terms. So f plus g, you can have 2x plus 3x is 5x, and 10 plus 7 is 17. G minus f, so subtract, make sure you do it in the right order. G minus f is going to be x, and 7 minus 10 is going to be minus 3. F times g, a little bit more complicated because now we're going to have to multiply. That's going to involve distributive property, 6x squared plus 14x plus 30x plus 70. Like terms, give me 6x squared plus 44x plus 70. Division is not very hard, f divided by g, because all you have to do is just say, let's divide. So we're going to take 2x plus 10 and divide by 3x plus 7. And sometimes maybe you could reduce, but not this time. That's just is what it is. Now, I know some students have a hard time with this composition. This is not the same thing as multiplication. What this says is we're going to plug a function into a function, f of g of x. So when I see this symbol, I prefer to think of it as this, f of g of x. I'm going to take x and put it into g. Well, I already know what that looks like. It looks like 3x plus 7. But I'm going to take 3x plus 7 and I'm going to plug it into the f function. 3x plus 7 goes into the f function right there. So the f function says 2 times something plus 10. I'm putting 3x plus 7 in its place, or in the variable's place. So just clean that up, distribute the 2, 6x plus 14 plus the 10 gives me 6x plus 24. 6x plus 24. Now the other one, we just go the other way. And so g of f of x just says we're going to plug f of x into the g function. So f of x is 2x plus 10. We're going to plug that into the g function. 3 times something plus 7, plug into x plus 10. That's 6x plus 30 plus 7, 6x plus 37. Composition. Imaginary numbers, I-25. I-25, okay. We know I is imaginary. It's supposed to equal a square root of a negative. All right. I squared is -1. I cubed is -I. I to the 4th is what? +1? +1. Okay. So the way I do this, I-25, is I like to find a multiple of 4 that's nearby. I know that I to the 25th is I to the 24th times I to the 1st. And the reason I like to find a multiple of 4 is because I know that every multiple of 4, whether it be I to the 4th, I to the 8th, I to the 12th, is going to equal 1. So I to the 24th is equal 1, and then we'd have to multiply times I. We're going to get I. I to the 25th simplifies just to I. It's always going to be, the answer is either going to be I, -I, 1, or -1 every time. Those are the only 4 possibilities, but in this case, we're talking about just I. Next one, I know people struggle with this one. It's kind of tough. We don't want an I on the bottom, so how we deal with that is we multiply by the complex conjugate, 2 plus 4i. Whatever you have on the bottom, just kind of copy it, but change the sign. So we're multiplying by 1, but a special form of 1, 2 plus 4i over 2 plus 4i. There's going to be a lot of distributive property here. So we distribute on the top, 5 times 2, 5 times 4i, and 3i times 2. That's supposed to be an I. And 3i times 4i. 3i times 4i is 12i squared. On the bottom, we're going to do kind of the same thing. Distribute. 2 times 2 is 4. 2 times 4i is plus 8i. Negative 4i times 2 is minus 8i. Minus 4i times plus 4i is minus 16i squared. Now what you're supposed to do is you're supposed to remember that I squared is minus 1. Try to memorize that. So if I squared is -1, then I've got 12 times -1 is -12, and I've got -16 times -1 is plus 16. I clean up my like terms. On the top of this fraction, 10 minus 2, or 10 minus 12 is -2, and 20i plus 6i is plus 26i. On the bottom, 4 plus 16 is 20, and those two things cancel out. So sometimes you'll want to split the fraction, and that helps to see how it reduces. You can reduce this fraction. Both of those numerators are even numbers. All of those numbers are even numbers. I can reduce this. That's going to be 1/10. And let's see, divide by 2, you get 10. Divide by 2, you get 13. We're looking at -1/10 plus 13i over 10. Simplified.